EIGRP is an advanced distance vector routing protocol. We're going to learn about EIGRP, just the basics here. So it's an advanced distance vector routing protocol. It's Cisco proprietary. It's Cisco created. It's run on Cisco routers. It was created to replace EIGRP or EIGRP, which was an earlier Cisco proprietary routing protocol. EIGRP was developed so that you could include subnet masks in the routing updates that go out to other routers, so that you could have variable length subnet masks and classless interdomain routing. So to do that, EIGRP was developed, and I have that on this bullet point right here. The differences from other distance vector routing protocols like RIP. Let's cover that. All right. EIGRP uses Reliable Transport Protocol, or RTP, in its EIGRP messages that go out from the router. It has both reliable and an unreliable protocol format. It involves a bunch of different messages. It's network layer independent by not using IP and using RTP instead. EIGRP can also support IP, IPX, and AppleTalk. Okay, so this is the protocol that talks to other routers. Another thing that is different about EIGRP from RIP is that it uses bounded and partial updates. And what that means is that EIGRP will send information to only the routers that need it, and it's only going to send the information that they need. It's not going to send out its whole routing table like RIP does every 30 seconds. It's not going to do that. All right, EIGRP uses dual, or the diffusing update algorithm, to guarantee free loops. This is the algorithm that's used by EIGRP, and it guarantees loop-free routes, and it'll also install backup routes. And the guarantee of loop-free routes is guaranteed by the complexity of the algorithm, and also because no hold-down timers are used like in RIP. EIGRP establishes adjacencies or neighbor relationships with other routers. It uses hello packets. That's once again the RTP protocol. It establishes these active neighbor relationships and with the neighbor routers. Okay, in addition to a routing table, which is the main table for a routing protocol, EIGRP has also a neighbor table, which it has those adjacencies that it's established in there, and a topology table, which has all the routes that it's learned in the network, lesser routes and backup routes. And these have to be loop-free routes. So these are often called the neighbor database or topology database. So, and oftentimes when you're learning about EIGRP, it'll say it maintains 3 databases or 3 tables. That would be the routing table, the neighbor table, and the topology table, which has all of the routes, even the backup routes. EIGRP benefits is a little bit similar to this last one. EIGRP has faster convergence due to no hold down timers, which RIP has. What does that mean, convergence? Convergence is when all the routers in your network know about all the routes. So if a route goes down, if other routers don't know that there's a route down, then the network is said to not be converged. And what you want to do is you want to have all the routers learn very quickly about any downed routes. So that's called convergence, and it's a lot faster with EIGRP. It uses less bandwidth on the network due to not having periodic updates like RIP sending out its whole routing table every 30 seconds. I put here, once again, it has bounded and partial updates. We've talked about that. It has backup routes, which are called feasible successor routes, and they can be installed using dual and the topology table. And if a best route or a successor route goes down, dual is able to instantly, EIGRP is able to instantly install a feasible successor or backup route from the topology table. And that's pretty nice if it has it. It can support IP, IPX, and AppleTalk using RTP and PDMs, protocol-dependent modules, which can be installed. It supports variable length subnet masks and classless interdomain routing. Once again, subnet masks are included in the protocol, so you can configure classless subnet masks. It's also capable of unequal cost load balancing if you have multiple paths to a destination network and they're of unequal cost, meaning different speeds on those links to get there. You can configure EIGRP to send packets out of multiple interfaces, even if those interfaces have different metrics. EIGRP defaults. Routers running EIGRP need to have the same process ID number or AS number to form adjacencies with their neighbors. Equal cost load balancing is on by default, but unequal cost is configurable. Okay, and then auto summarization. EIGRP summarizes routes by default. Oftentimes you're going to have to turn this off in EIGRP. So auto summarization I have there. Next section, EIGRP messages, RTP. Here's some of the messages that go out from an EIGRP router. It sends out hellos every 5 seconds. It's an unreliable protocol here. It has replies. Replies are sent in reply to queries. Queries are the next type of message it sends out. And updates and ACKs, acknowledgments. And then you can see that some of these are multicast and some of these are unicast. And some of them are reliable and some of them are unreliable. Okay, in the EIGRP messages or RTP protocol, you have the EIGRP header, which has a field called the opcode field, which tells which kind of EIGRP packet, i.e. hello or reply and whatever. And these will have a different number. And I didn't list the numbers here, but you can look them up. It also has the AS number or process ID number for the EIGRP process sent in that header. And then in the EIGRP data area, there are the TLV fields, and those have the internal and external routes which are sent over those fields. And also the subnet mask data is sent over the EIGRP data fields. And so that's the EIGRP packet right there. All right, and down here we'll keep talking here. Successor and feasible successor routes. Successor route is very simply the best route. That's the route in the routing table that dual computes to find the best route to a destination network. A feasible successor is going to be a backup route, and that's going to be in the topology table or topology database. To have a feasible successor, the route has to meet the feasibility condition. And I got that here. What is the feasibility condition? That is, if the neighbor's route reported distance, right, to a destination network is less than your router or the local router's feasible distance. So the feasible distance is my destination to a given network, and the reported distance is the distance that gets reported to me from other routers. So I learn about a distance from another router, that's a reported distance, and then I calculate a composite metric, and then I have my feasible distance to that network. Okay? And then configuring EIGRP, I've got some basic configuration commands here that you're going to want to know. First of all, how do you turn it on? You need to go into global config mode, and you just type router space EIGRP space and then a process ID number or AS number, which is, in this case here, you can see a 1. I put a 1 there. And then you have to put in your networks. So the next commands are going to be network and then a space and then the network address, and then wildcard bits. And wildcard bits are interesting. Wildcard bits are the opposite of a subnet mask. So if my subnet mask was 255.255.255.0, the wildcard bits would be 0.0.0.255. And how do you get that? Well, you just flip the ones and zeros. If you just change all the ones to zeros and all the zeros to ones, you'll get these. So here you can see I've got one for a 24-bit subnet mask. I've got basically a 24-bit wildcard bits. And then here it would be like a /30 subnet mask, and this is what the wildcard bits would look like in the /30. So then I've added a network, and then here you can also just add a network and not put a wildcard bits or subnet mask, and then EIGRP will assume it's going to be a classful wildcard bits or classful subnet mask. Okay, another important command is the no auto summary command, and that will turn off auto summarization by default. I've already said that the no auto summary command will turn off summarizing routes for EIGRP, and then the next command I put here is redistribute static. This will advertise default routes or static routes to other routers in the EIGRP AS, so autonomous system, or all the EIGRP routers have the same process ID. This is useful if you have a default route to like a 000 network with a 000 subnet mask, and you want to send out that static route and let other EIGRP routers learn about it. Then you'd use this redistribute static command. And then over here, some other commands that you might need to know about. If you were to go into interface mode, so here you see I'm in global config mode, and then I put in interface serial 000. That puts me into interface mode, and then I can put a summary. I can manually put a summary address on my interface and attach it to the EIGRP process. even from interface configuration mode. So this is the command that would do that. IP summary-address EIGRP1, the EIGRP routing protocol and the process ID, and then the summary address that you want to use and the summary subnet mask that you're going to use. Okay, so that's a manual summary address configuration. And then another thing that Dual needs, that the EIGRP algorithm needs to run correctly, is you need to configure bandwidth on your different interfaces. So here you see I've also gone into interface serial 000, and then you put in bandwidth 64, and that's going to be 64K, 64 kilobits bandwidth setting, so that Dual can calculate the metrics to the destination networks correctly. Okay, the administrative distance for EIGRP is, for an internal route, is a 90, an external route is a 170, and then a summary route, if you have an EIGRP summary route, that gets a 5 and as an administrative distance. Okay, so here I've got some basic EIGRP configuration commands. You can see here I got a screen grab from a config, and I've got it up here. I've got my EIGRP command, my network commands, no auto summary. I've also got the bandwidth and another bandwidth command here. Okay, and then we can examine the routing table. If you look at the routing table here, you can see that if you see a D on the left-hand side, that means EIGRP. C stands for connected route. So you see here that we've got some connected routes, and then we've also got some routes with Ds that we've learned about from EIGRP. And you can see here the parent routes are here, and the child routes are indented. So we look at this one, we see here that this parent route says it's variably subnetted, 2 subnets, 2 masks, and then we've got 2 child routes. The first one here is a summary route to the null 0 interface, and this is important. This can cause some problems. The summary route to the null interface will mean, in this case, that after looking through the routing table for a route to a child network, if it doesn't find a child network, it won't continue on and look for a default route or a static route. So it's important that we turn off auto summarization to bypass this situation. And let's see here, we've got some other another summary route to a null 0 network. You can see here I've put an explanation here down to that, and then some child routes here. You can see here that this in brackets here, this 90 is the administrative distance for EIGRP, and then this number 2,172,416, that is the calculated metric by Dual to the destination network. The lower number being better. So anyway, that's something that shows you a little bit of the routing table. If you were to put in a default static route and then put a redistribute static command, which would distribute that route, it would look something like this. You hear D for EIGRP, and then an asterisk for a default route, and then EX, it's labeled as an external route, and it's to the 000 network, and you can see here it gets an administrative distance of 170, and then here's the metric over here via the next hop router's interface and out of serial 0. All right. Another important command that you want to know how to do for the test is the show command, show IP EIGRP topology. This is important, and it'll probably be on the test because it lets you know, when you put in this command, it lets you know all of your EIGRP successor and feasible successor routes. And you can see here if it's a P, that means this is a successor route. It's a P, it's passive, meaning it's a good route. The route is in place and it's fine. If it's an A or an active, that means that EIGRP is actively searching for a new route, and Dual is computing. So we've got here the 10.1.1.0 network is a successor route, and it has a feasible distance is, and it tells you the feasible distance right here, and it tells you here connected via this address. When you have these two numbers here inside of parentheses, the first number is the feasible distance and the second number is the reported distance. So my guess is, like on this one, we've got a feasible distance number. That's my distance to this network, EIGRP distance. And then the 0 means that reported distance is 0, meaning I probably learned about this route on a connected interface since there's no reported distance. So it's probably a connected route. Down here at the bottom, I've put in some configuration commands if you wanted to set up maybe unequal cost load balancing and how you would set that up. Well, I hope this was helpful, and in the next video I'm going to show a little bit more about looking at EIGRP using Packet Tracer.